Okay, we're good to go. I'm going to do a little poll, kind of the 1 to 3 thing that we've been doing with some concepts, and that'll help me kind of know what to focus on for review, but I'm going to do it a little bit differently. So I'm actually going to be able to see numbers, and it'll be slightly more anonymous, not actually anonymous, but it'll feel a little more anonymous if that helps. One quick thing, if you haven't posted an emoji in the thread, please do so. That's how we get our attendance metrics. I'm going to give folks a minute to do that if you haven't done that. Do want you to do that every time. Oops. Okay, it looks like we've got 30 people in the call. We've got 26 who have replied, so we need 4 more. $27, $28. Let's get one more. Okay. We got 2 people who don't want to post. That's okay. I'm going to let it go. So let's do this way. So I'm going to post this in, and then I want you to wait a second because I'm going to leave a couple emojis on it, and you can click the one that corresponds with you. So it'll give you a second to think about this. So while I'm doing this, I'll let you know when you're clear to vote on this. I'll let you think about this concept. How are you feeling on these list concepts overall? These are going to be lists in general, indices, subscripting, and slicing. So you can click 1, 2, or 3. Okay, yeah, there you go. Go ahead and click, instead of putting it in Slack, just click on the emoji that corresponds with 1, 2, or 3. Wait. Don't post it in Slack. Hold on, sorry. Don't post it in Slack. Click on the emoji underneath the message that corresponds. There's 3 emojis under the message. A 1, a 2, and a 3 from left to right. So you can just click there to put in your answer. So I know I'm doing it a little different. Changed it up on y'all. Okay, we need some okay, some guidance on this one. So I'm going to paste in a picture, which will show you where to click. Okay, so we got mostly 2s. So I will kind of dig into these concepts as they come up then. Let's do a similar thing for range. So don't react just yet. Give me 1 second. I know the copy is the same on this one, but I will edit it. range function. Interesting. Wow. This method seems to yield wildly different results than the other one. Or perhaps I'm just seeing it differently. That's interesting. So it seems like people are generally better on the range function than with lists themselves. Okay, cool. Good to know. We will, whoops. I have to get my screen share up and going. Okay. So I'm not going to spend much time on review. Well, we're not going to do review directly this time. Instead, I'm just going to cover list and range concepts as they come up. They will come up in what I have planned for today. So I want to do, I guess this will be sort of review of what we've done with for loops and just, you know, kind of solidify what we've talked about with for loops. I'm going to do a little exercise that I kind of referred to in my mind as the gauntlet of primes. I'm going to write a few sort of prime number functions. This isn't the full prime number function exercise that I will often do, but this is kind of part of it. And we can, just these three functions, we can kind of look at some interesting ways of writing code and some interesting things about prime numbers too. I do want you to code along with me for this if you can, and I'll post my code as we go through. So, quick overview. So, if you're curious, I think I've said this before, and I know I do this overview every time, and I feel that by now you at least have these topics memorized. This is probably not really new. The reason I do this every time is a lot of people ask me like what we're expecting for the TI. We really need to see Python proficiency. It's important that we see people have a solid grasp of core Python concepts. I think it's easy for people to overestimate our expectation for math and stats. Of course, we do want you to have some math and stats foundation as well. We've talked to my team has communicated with the instructional team for the DSI, and their consensus is that they are, and the material is prepared to teach people the math. What they can't really do is help somebody who really struggles with Python. So Python coding tends to be more of a limiting factor more often in the DSI than math and stats. I'm not telling you to like just ignore math and stats. You know, like obviously we have that material there for a reason. You know, we want you to go through it and have a sense of the distributions and things. But we look for that core Python proficiency as a pretty primary thing when we give the TI. So when I talk about, that comes down to defining, well, what does it mean? Exactly what does core Python proficiency mean? And it's this, plus you'll need to know how to import. But importing sort of falls in amongst, where would I put importing? I would put importing in, I guess, data types, because you're pulling in libraries that are classes that are really other data types at the end of the day. But I'm not going to talk about importing as much directly in Premium Prep, not because I want to like shield it or anything. Just it's in the material, and it's just not. There's not that much to it. You just pull in a library, you say import the library name, and then you use stuff from the library. So there's might seem a little intimidating, but there's kind of not as much to it. So I might go over importing concepts in a study hall at some point. So keep your eyes peeled for that. All right. So that's why I keep going over this overview, because I want you all to know what we expect you to know. If you have a sense of the built-in data types in Python, if you know how to use the two abstractions that we go over, variables and functions, if you can write at least decent control flow can get a little tricky, and there's kind of a good enough point, like you just need to make sure you understand the differences of how different if elif else sequences kind of work. You don't have to have that down like totally crystal clear, perfect, just as long as you can make it work. And iteration, accumulator pattern stuff with for loops and while loops, which is kind of what we're going to be talking about today. If you know these things, I would say you have a solid grasp of core Python concepts to the point where you can utilize Python to do meaningful problem solving, and then we can work with you. We can help you learn data science. That's what the data science instructors need. So that's why I keep going over this, because I want to make sure it's like second nature. You know your data types, you know your abstraction, you know your control flow, and you know your iteration, and you know what tools we want you to know. So we've got int, float, bool, string, none. We've talked about lists. We haven't gotten to it yet, but soon we're going to talk about tuples, sets, dictionaries. We're going to be talking about those as well. I'll just put an asterisk next to the ones we haven't gone to yet. Abstractions, variables, functions. Control flow, you've got your if, elif, else. You've got various operators, less than, greater than, equal to, not equal to, greater than, equal, less than, equal. We've got not and an or. Understanding Boolean expressions in general is helpful here. Iteration, we're going to be covering for loops a little more today. I want to kind of like go pretty quickly through this stuff. I do want you to code along with me. If you're getting errors, just do your best to keep up. I'll try to open up for questions sometime in the middle of class. We can troubleshoot, catch some bugs. If you have questions, if you're stuck on something, we'll do that together. You can also feel free to ask as they come up. and then we will move on to the second half of today's lesson. I intend to get to list methods and operations. There's a lot to get through with this. I don't expect that we're going to get through all of it today, but I want to try to at least kind of lay the foundation of what this is and kind of map it out, and then get through as many of these as we can. Okay. So iteration, we have for and while loops, which we haven't talked about yet, but we'll get to those. All right. So I was looking through the material today, and I saw the isPrime function. There's a couple ways that this function appears in our material. It's often used to give an example of Boolean flags because it can be written. It can be written in this manner with Boolean flags. So I'll just talk about this function real quick. Let's just do this. This function, let's do the isPrime function. And I'm going to talk about a Boolean flag version and a non-Boolean flag version. So, and I prefer, to be clear, I vastly prefer the non-Boolean flag version, but that's, just how this works. Okay. So isPrime. Let's do a little quiz. I mentioned this a while ago, real early on. Whenever you're learning a new function, or you want to gather information in order to write a new function. So you're either learning how some new function that's already written works, or you need information to tell you how to write a function. I laid out 3 things that you want to know. I gave it a little acronym. I meant to mention it more often and I didn't, so I apologize. But I want you to kind of search your minds for this a little bit. I know a few of you have been through Premium Prep with me before. You've heard me talk about it. I want to just give you a second with this. So, what pieces of information do I want to know when I'm writing a new function or learning a new function that's already written? Oh, is there background noise? I'm sorry, I have a fan on me. That looks like that's better. Let me see if I can turn this on. I think I had a fan like blowing directly on my mic. Apologies. Let me know if that background noise went away. Cool, good. Okay, so we got a few answers in here. Yeah, I see a lot of like musing on this. Feel free to just muse on it. Maybe you'll think of a structure that makes sense for you that I didn't think of. Just put your ideas out there. Okay, cool. We'll go with this. um, so what I went over this time, usually I go over IPO, which is input process output. I decided to go with a slightly different version for this class, and I called it ION or ION, which is input output notes. And I just wanted the I and the O next to each other because it's really important to know to keep track of what your inputs are to this function and what your output is. So what does it take in? What does it need? And what does it give you back? What do you need to give it? And what can you expect it to return back to you. And sometimes those things are pretty simple. Sometimes they get a little bit complicated. If you recall in range, I don't think range's inputs are terribly complicated. Writing them out is kind of feels kind of complicated when you actually like try to write out the input rules for range. But if you just remember, you know, that it takes start, stop, and step, and it will assume a value for start and step, and it takes at least one value, and if it takes one value, that value gets plugged in for stop. If it takes two values, the values get plugged in for start and stop. And if it takes three, then the values get plugged in for start, stop, step, in that order, right? It's a little funky. But I don't think it's like totally terrible, right? So for this problem, for this isPrime function, I want to have some sense of what it's supposed to do, so some notes or a description. Usually the description will go first. If you want to follow the ion thing, you can put the notes at the bottom for a description. But by convention, there's sort of this, there's a different conventions around this, but descriptions, input, process, output kind of format that you'll see. So there are different conventions around this. So I'll usually do the description first, and then inputs and return. And of course, output is a synonym for return. Let's say return/output, and parameters is a synonym for inputs, parameters, arguments. Parameters, arguments, inputs, you know. These two technically have slightly different meanings, or they apply in slightly different scenarios, but you know, they're all of a piece. They're all describe the inputs to a function. Okay, so what's the isPrime function supposed to do? Well, tell me if a number is prime or not. So it tells you if a number is prime or not. Obviously, I'm kind of just writing casual here, casual like. All right, the parameters are just going to be n, which is an int, and it will be, or let's do it this way, a number to determine whether, I mean, it's the number we're going to see if it's prime or not. I'm not even going to write it out. So n is an integer, and then the return value is a bool, true if n is prime, else false. Okay. Give me a thumbs up or a thumbs down if you have a sense of what isPrime is supposed to do or not from this. Thumbs up or thumbs down in Slack. Real quick. I'm not sure what I'm going to do if somebody gives me a thumbs down for this, but I think it's good to just kind of make a ceremony of it, you know. So let me know if you get it. If not, I'll do my best to explain. Okay, I'm getting a sense that people are getting this. Great. Okay, so let's write an isPrime function. What's the first thing that I should do? Writing a new function, I have a sense of what it's supposed to do, right? I have a sense of inputs and outputs, and you know, just a quick description tells me what it's supposed to do or not, or tells me what it's supposed to do, tells me if a number's prime or not. First thing is define the function. So there's something I like to do before I define the function. And it's sort of a piece with, like I like to go into solving a problem I mean, I've written this function, oh gosh, I don't know, hundreds of times in various versions, and I'm looking at a version of it right here. You know, I know how to write this function, but with anything, I like to practice good form. I like to practice good form even if I know how to solve it. So before I define it, there's something else that I like to do. Um, I'll try to get a quick doc string with input, output, notes in it, and um, there's one more thing I like to do before I write the definition. Let's see. Oh, interesting. We've got a wide variety. Somebody did say the thing I like to do. I'm seeing if anybody else says it. Determine the parameters and the desired output. Yeah, so that's what we did here. I mean, that's fair enough. I mean, I guess I do like to do that before I define it. I guess I think of this as like step 0. I think maybe I do like zero-based counting in my head because I've been programming so much. Okay, so what I like to do even before I define the function, obviously I have a problem statement or a doc string with my inputs and outputs noted in some way. Next thing I like to do is write a test. So there's a lot of ways to write tests. The ways that I show here are just simple print tests. You'll usually, you can keep it really simple and just call your function is prime. And let's just give it a number we know is prime. 3 is true. And a number we know is not prime. Let's just do 4. 4 is false. So we know if we write our isPrime function correctly, this first one should give us true, and the second one should give us false, right? And I like to do this because it sort of reinforces this. I mean, this basically is telling me input output, right? And if I name the function well, it kind of gives me a sense of what it does. It should, at least, right? So that's kind of like notes, or at least telling me a description, what it's supposed to do. So a lot of times I will actually skip this and I'll just write tests, and that basically is my documentation. And that's okay too, in a lot of cases. Okay, so what I'm actually going to do for testing this is I'm going to throw this in a for loop. I'm going to say for I in range, we'll do 0 to 20. And that's actually going to be up to 19, but it doesn't really matter. Just we want to do a few tests, but not a whole bunch. And then I'm going to print I, and then I'm going to pass I to isPrime. And so what this is going to do is it's going to print I and then true or false of isPrime of I, right? Which will tell me if I is prime or not. So I'll see I and true, or I and false, or the number and true, or number and false if the number is prime or not. Okay, so I've got this for loop. We're iterating through a range. I technically don't need this 0 here, really just range 20. I'll keep it there just because it'll make it easy. If I want to start it somewhere else, I can do that. But I'll just keep it there for now, even though technically it defaults to 0 anyway, so I don't need to pass it. Okay, so I highly recommend doing this because, like, think about it right now. Is your idea, is your conception of what isPrime is supposed to do, isn't it a little clearer now that I wrote a test, right? And you might, I think a lot of people are like, okay, I wrote the inputs and outputs. Now I want to get to the good part, right? To me, testing is kind of the good part. I find like it's interesting to think through the problem for sure. I mean, I enjoy coding, and it's fun to like get into the problem and start thinking through the problem itself. Um, but the test is what proves whether you got it right or not. So it's not only useful, but it's also an interesting thing to spend some time on. So, this is a meaningful part of coding. This is, and it is in the TI as well, right? You don't have to go hog wild with it in the TI. You don't have to do anything fancy at all. Just do a print to your function and say, well, I guess if I gave it this input, I'd expect something like this, right? And a lot of times I'll take a note of my expectation and a comment. In this case, I don't want to write out what I expect for every number between 0 and 19, so I'm not going to do that, but I can recognize a prime number under 20 pretty easily. I can just think, does that number have any other factors pretty easily? And there's a number of primes and a number of non-prime numbers under 20. So it's a good little sample set to test primes on. So this step, at least calling your function before you write it, before you define it, I highly recommend that you just take the time to do that. Okay, so now we'll just do a stub, which is just this. This is just a little function stub. And the reason to do this is I want to run it, and right now I'm basically just testing the test. I'm just making sure I didn't do something like leave off a colon or do something weird with the range, or leave off a comma or parenthesis or whatever, right? I just want to make sure I'm on clean code and I'm starting this problem with clean code, and it's going to make it easy to work through and solve this. Okay. So let's keep track of some of the steps. Get a sense of the inputs and the outputs and take some notes on what it's supposed to do, anything that might be important. Write a test, doesn't have to be in a for loop. In this case, just easy to test a bunch of numbers this way. So write at least one test, maybe two. And then write the stub for your function, run everything. You're going to see a bunch of nones here, but that's what you expect, right? If you didn't see none there, then you'd have to at this stage, you'd have to say, oh, wait, what's going on? Something else, I made a mistake somewhere, right? So you want to see this list of nones here. Okay, cool. So now let's do is prime. So we're gonna do the, let's see if I'm gonna do the Boolean flag version without looking at it. I don't often write the Boolean flag version. So when I start off with a Boolean flag, I don't think about whether I'm supposed to start it at true or false. You can sit there and kind of brain it out if you want, but I don't know. Maybe I'm lazy, but I just guess. So I'm going to say prime equals false. And I know I'm going to be returning prime. So let's do this. If I have a bit of an edge case, somebody mentioned edge cases somewhere in there. So edge cases definitely are something that you handle early on in a lot of cases. So I'm going to handle an edge case. I'm going to say if n is less than 2, we're going to return false. We're just going to return false like that. The number is not a prime. We're not even going to bother. We're not going to do anything. So real quick, what happens? Okay, I'm defining a function. I invoke the function, down here, the function is invoked. What happens when the function encounters a return? We got a few answers. Cool. Yeah, we got a few answers in here. Somebody's saying, somebody put in, depending on where the return is, it may stop. So the way I would say this, and I want to kind of address the way you put that statement together. The way that I would say this is that when the function encounters a return, it returns the value and it exits. It stops executing. It doesn't execute any more code. So to clarify, what I mean by encounters is it runs the line on which the return is on. So this line may or may not be executed, because if n is greater than or equal to 2, it's not going to run this line. So that's what I mean when it encounters a line, when it encounters a return and runs it. The way you're putting that is accurate in the sense that depending on where it is, right? Like if it's in a condition, the Python interpreter will parse that part of the code, and it'll know, oh, well, there's a return there, but since it didn't execute that line, it's not going to return the value and stop the code. So I thought it was a good opportunity to kind of clarify that. Cool. Okay. So let's do this. Let's say in order to tell if a number is prime or not, one way you can, well, the only way that I know how to do it is you check you don't actually have to check every number, but you check a set of numbers starting at 2 up to there's several places you can go up to. The shortest is the square root. So you check some group of numbers underneath the number you're trying to see if it's prime or not. And you check them by seeing if any of those numbers, starting at 2 and going up from there, any of those numbers is a factor of n, right? So I'll show you how to do that. We'll say for I in range 2, and I'm not going to write the most efficient version of this. I'm just going to do n over 2, which is half of n. And I'm not writing the most efficient version of this because I don't want you to get caught up in the minutia of like how to exactly like get the smallest set of numbers. That's not important. We're going to write a working is prime function. It's going to be a little less efficient than it absolutely could be, but basically what I'm doing here, range needs integers. I want to check from 2 up to half of n. If I divide n over 2, I may get a fraction. I could use floor division here, but if you're in study hall, I actually went over why I prefer to use int in this case over floor division. And then we want to include this halfway point. There are certain cases where we might want to include it. I think, might be wrong about this one. I know we have to include it when we do the square root. But yeah, I'm just going to write it so that it's inclusive of the halfway point. So I'm going to say +1, and that +1 in this place just means that this number is included. Half of n is included. And the int just makes it an integer. Okay, so that's the set of numbers we're going to check, and then I'm going to say if n over I has a remainder, so in order to do the remainder, I'm using the modulo function. If n over I has a remainder of 0, we're going to return, nope, we're doing the Boolean flag version. Okay, we're going to say prime equals false. Prime equals false, okay. So I started this at prime equals false. Remember when I said I don't think about whether or not I need to start it at true or false? This is a kind of a strategy that you learn to pick up, or at least I've found very useful. Maybe other people don't do it. I really recommend it. There's a lot of times, there's a lot of places where I don't need to spend any mental energy to figure out what I should do in a certain place, because I'm going to find out soon anyways. I know I'm going to find out. So with something like a Boolean flag, I don't know if it's because I'm dyslexic or whatever, I often find it difficult to think, well, am I starting this at true or am I starting this at false? And I'm thinking through the problem and I'm like, oh, I'm kind of racking my brain. I could sit here and do it, I'm sure, but I know as soon as I get into the problem, as soon as it comes time to flip it, it will be clear to me where I should have started it. So what I do is anytime I like take a guess, like just hazard a guess somewhere, I just kind of take a mental note, like I wasn't totally sure about that, so I have to come back to that and address it in some other way. So in this case, I see that I'm switching prime to false, and if I start prime at false and switch it to false, there's no case in which I can return prime as true. And I know if I get through this whole range and I check every I value and I don't find any value of I that divides evenly into n, then I should return true, which means I should not have changed prime from true to false, which means I need to start prime at true, right? So at this stage, it becomes obvious to me, having made a mental note that I made a guess somewhere, it becomes obvious to me that I need to start prime at true. Okay, 1 second, my headphones are beeping at me to plug them in. I have to take them off to just do that. 1 second. Sorry about that. Okay. Ready to go. So let's just look at this real quick. So remember our edge case, 0 and 1 are false. These are not primes. 2 and 3 are primes. 4 is not a prime. 5 is, 6 is not. 7 is, 8, 9, and 10 are not. 11 is, 12 is not. 13 is. 14, 15, 16 are not. 17 is, 18 is not. And 19 is a prime number. So this appears to be giving me the correct output. Okay, so this is the Boolean flag version. There's several reasons I don't like it. One is, once we determine, okay, let's say n is 10. So let's just write a test for this. Sometimes if you're trying to think through a scenario, it really helps to just write a test for it. Oh, I'll just do this, I equals 10. Okay, so I equals 10, 10, false, not a prime number, right? But here's the thing, 2, excuse me, sorry, my voice broke there. 10 is divisible by 2. But we go through, this range is from 2 to int 10 over 2, which is 5, plus 1 is 6. So this range gives us numbers 2, 3, 4, 5, right? So we check 4 numbers. So the first number we check is 2. In 10 over 2 equal 10, excuse me, 10 mod 2, if 10 mod 2 equals 0, which it does, prime equals false. So at this stage, as soon as we find a divisor, we know the number's not prime. But the way this is written, it's going to keep checking the rest of the numbers. There's nothing telling this to like stop checking numbers, right? So this is not a big deal with 10, but it's a bigger deal with 100, and it's a bigger deal with a million, you know what I mean? A million is divisible by 2, right? It's 500,000, right? But we're going to check every number from 2 up to 500,000 if we were doing this with a million. Oh, I don't know. There's a lot of. I'm going to try to actually write a million. Oh, I got it. Okay, good. Yay. So this is going to check 500,000 numbers. But the thing is, I only need to check that one, and that very first number tells me that this is not a prime number. So this does for this number, it does 499,999 iterations that we didn't need to do, and we can provably avoid, right? So there is a way around this with the Boolean flag solution, and it brings me to one of the things that we didn't get to talk about for loops, which is break, right? So under this condition, I would want to tell the loop to stop. When you want to tell a loop to stop looping, you say break. And break is a keyword. Notice it highlights red like all the other keywordy things, right? So break is a keyword that is only valid inside of a loop, and it bears on the loop that it is most immediately inside of. So if I have 2 nested loops and I have a break inside the inner loop, the break does not apply to the outer loop, it applies to the inner loop. So I think it's safe to say you will always find a break under a condition, because if it weren't under a condition of some sort, then the break would just be in the loop body directly, and you'd never get more than one iteration out of the loop. So it makes sense to always have the break inside of an if, inside of some condition, so that it will only run sometimes. Oops, let me get a little light in here, sorry. So break is good for stopping the loop. And it doesn't just stop one iteration, it just stops all the looping, right? So let's try this, let's do a little kind of a fake benchmark here. Let's just print start, and once this is done, we'll print stop, right? So without the break, let's see. Oops, well, that went pretty quick. Let's try to add some more zeros. No, that's too many. Let's just do 10 million. Okay, 100 million? Okay, now we're gonna have to wait a little bit. Okay, now it went. So you see there was a bit of a delay. So if I run it, 1, 2, 3, 4, 5, 6, okay, about 6-second delay. And that's where it has to go check basically 50 million iterations that it didn't need to check. So if I do this break here, it's going to exit on the first shot and it runs instantly, right? So that break drastically improves the efficiency of this. There's not many times where I'm going to be like, often I'm like, don't worry about optimization, but in a case like this, like that is so much better, drastically better. Let's see. Somebody's asking, why use a Boolean flag when we can use elif? A Boolean flag, well, Boolean flag in this case is this part right here. This is the flag. And all we're doing is just switching this from either false to true or true to false. And there's cases where you'll start it at false and switch it to true or not, or start it at true and switch it to false or not. In this case, we're starting at true and may or may not be switching it to false. Once the loop exits, it'll return the prime number. Somebody's asking, can't you use a counter and set that counter if it's over 1 to stop the loop? Oh yeah, you could, but you'd end up using a break here anyways. Cool. So anyways, this is the Boolean flag, the better Boolean flag version that uses break. Okay, the version of this that I prefer is going to use no Boolean flags. Just get rid of it. We're just going to return. Remember how return just stops the function? Let's just return false. And if we make it through and check everything, let's just return true. So if we make it through, if we make it to this line without having returned false, then we know the number, you know, if the number is not divisible by anything, so we can just return true. So that's the version I prefer. I find this to be simpler code. Return has the effect of break. I don't have to like, I often, I don't know why, I often find Boolean flags like at least slightly challenging to like keep track of when it's supposed to be true and false. They're not terrible. I can always think through them, but like I always have to like, I'm always, when I'm doing a Boolean flag solution, I always feel like I'm stretching my brain like a little bit. And this, I just feel like it's just rolling off a log. It's like, it's just so natural for me to just say, oh, well, if n mod I equals 0, just return. We know what value we want to return at that point. We don't need to break the loop, just return. Return breaks the loop and the whole function. So it exits the function mid-loop, which is a de facto break to the loop. So that's my preference. Like I said, there are other optimizations that you can make. Here you can check, there's like a whole host of ways to optimize the isPrime function, but this one's not fully optimized. It's got this optimization in it where we're not checking all the way up to n minus, not including n, but yeah. Okay. Cool. Well, that took me a lot longer than I thought it would. There's just never enough time in these classes, I swear. I'm like, 2 hours, it's so long. Every single lecture, I'm like, it's so long. And then as soon as I start, I get 10 minutes into it and I look up and it's been an hour, so. You'd think I'd learn by now. Okay, I want to get through these before we take a break. So we'll take a little bit of a later break today. Sorry about that. I'll try my best not to do that, but this time I just want to be able to get all the way through these. So next prime. Let's write a doc string for next prime. So I'm going to do inputs are n, which is an int, and outputs int, which is the next prime number. The next prime number after n. Notes, we'll say takes n and returns the next prime number after n. If n is prime, it does not return n. So if I give it 13, it's got to give me back 17. Excuse me. Okay. So there's my notes. Next prime. So this is going to get us into, I'm going to give you a little window into while loops. So I'm actually going to just do the same kind of tests here. A lot of times when you write a function that just takes in a single integer, you can just test it with a bunch of integers in a for loop, and that'll make sense in a lot of cases. Test it real quick. Okay. So for this one, we have a couple ways we could approach this. For one thing, we have a bit of a problem, which is we need to loop over numbers. We need to check every number after n and just keep checking numbers until we find a number that's prime or not. So this kind of looping pattern where we have to just keep going until we encounter the correct situation can't be solved well with a for loop. There are kind of ways that you can get a for loop to do something like this, although a for loop is not made for this. There is a different looping structure called a while loop that is well suited for this, that is designed for this purpose. So a while loop it's a loop. You know, I always put it under iteration the times that I've brought it up. It belongs, categorically, it belongs in this category because it does iteration. It repeats processes like a for loop. Its job is similar to a for loop. The way it functions, weirdly, is similar to an if. So let's look at how an if functions. So an if takes a condition. If the condition is true, it executes the code in the conclusion. It executes the conclusion, the body, whatever you want to call that. So it does the code, it will run the code in the body of the if the condition is true. If it's false, then it won't. So a while does something really similar. So when an if executes the code in the body here, it just continues down the document. The difference, this is the moment where there's a difference between an if and a while. So a while checks a condition. If the condition is true, it executes the code in the body. Then when it gets to the end of the while loop, rather than just continuing, it goes back up and it sees if the condition is still true. So with a while loop, you have to make sure that your condition, part of your condition changes in the loop, or something in the loop changes that will change your condition. If you don't do that properly, you will end up with an infinite loop. You will end up with a while loop that never exits. And Python will allow you to do that. And if you're not printing anything, especially in the loop, it'll just look like your code froze or it's not running. If you're running locally, you might notice your computers start to get hot because it's just whirring away back there with this while loop that's just going and going and going and going and going and going. So you want to be careful with while loops, and I'll introduce these again a little bit later and go over a little more how to control them. But for now, suffice it to say, you want to be a little careful with while loops. So they are very powerful, and they can solve, they're well suited for solving problems when we don't know how many iterations we need. So there's a couple ways we can solve this. One is we can write this is prime logic, a Boolean flag version of it. We can write a Boolean flag version of it in line, or we can write an isPrime function like this and just use it in here. So let's write the Boolean flag version first. So for the condition, I'm going to do something kind of crazy. I'm going to say while true. And what this is an explicit infinite loop. When I see a while true, what I'm assuming is going to happen, and what I intend to do when I write a while true, because remember, a condition is any expression that evaluates to true or false, including true or false. So when I write a while true, I'm basically declaring my intent that in some point in the while loop, I'm going to check a condition that will tell me to either run a break or a return. So I'll either run break or return. So first thing I want to do is I want to increment n. N plus gets 1. And this, if I do this right away, it means that I'm not going to check n itself. And I don't want to check n itself. Remember, if n is like 13, I don't want to check. If 13 is a prime number, I want to start checking at 14. If n is 12, I want to check 13, and 13 is a prime number, so I'll return 13, right? So let's do the Boolean flag version of this. I'm going to do prime equals true. Then I'm going to say for I in range 2 to n, and we'll do this again, int n over 2 plus 1 if n over I has a remainder. So in other words, if n mod I equals 0, then prime equals false. Prime gets false. Now I have this flag, and I can check if prime return n. So I'm pretty sure, I don't usually write this version of next prime, and I always get a little nervous with while loops. I'm pretty sure this is going to exit, but I don't know. We'll see. Yay, okay, cool. It didn't break, and all the numbers on the right, looks like these are all primes. This is wrong, though. I forgot to take my edge case. So if n is, what should I do for the edge case? Maybe I'll just handle it. I guess I'll just do this. I guess I'll just say if n is less than 2, I'm going to return 2. I think that's what I want to do. Yep, okay, cool. And then 2 is a prime number, the next prime is 3. 3 is a prime number, the next prime is 5. 4 is not a prime number, the next prime is 5. 5 is a prime number, the next prime is 7, etc. Okay, so this is working as intended. So this is, I wanted to show this version of this because if you wanted to write the is prime logic in line, you need the Boolean flag. You need to do it with the Boolean flag. The other way of writing this is while not is prime n plus 1, n plus gets 1, return n plus 1. So this is nice. This is a nice simple function. This is, it's not terrible. I've written much hairier functions, but by comparison, this is pretty hairy in comparison to this solution. So if you have an is prime function written, and hopefully this kind of gives you a sense of, if you have this is prime function written, use it. You can use it, and this function isn't too bad on its own, and this function isn't too bad on its own. But if you write it this way, you're redoing a lot of work that you already did in a function that you wrote. So it's kind of nice to use helper functions and write things in a way where each function is kind of a clear, simple idea of its own. It makes your code really readable. Like I said, this isn't too bad, but there's obviously a lot more going on than with this. So let's try that out. And you can see this is just naturally going to work. I don't even need that edge case. This is just naturally going to work with that numbers under 2. So, like I said, yeah, the reason that I wanted to go over this solution was to show an actual case where you might want to write an is prime function, or where you actually might want to use a Boolean flag if you wanted to do this in line, and then you kind of have to do it that way. Yeah, cool. Okay, we are way over our halfway point. So let's take a break here, and let's reconvene. Let's reconvene at 18 minutes after the hour. That'll give us about 5-minute break. I will take questions. The questions that I see right now, I'll take them. Oh, I guess there's just one. Can I walk through what the while loop is now doing? The why not is prime. Yeah, I'll do that after the break. Cool. Break. All right. Cool. That's our break. I'll give you all a minute to sit down and get ready. A few seconds here. Great. So somebody asked that I walk through this. And talk about what this while loop is doing. So the while checks its condition. If the condition is true, it executes the code in the body. Now in the body of this while loop is just an incrementation of n. I'm checking n plus 1 because the same thing, if I take in a prime number, I don't want to check n. I want to check one more than n. So I want to see if the number after n is prime. And if it's not prime, is prime returns false. However, while I want a loop while the number is not prime, actually. So I want a loop in the opposite case, right? So if n plus 1 is not prime, then I want this condition to be true so that I can increment n and then see if that n plus 1 is prime, and if it's not, then I want to increment n, right? So I need this condition to be true when is prime is false. Does that make sense to everybody, to the original asker? Or anybody else? Good, cool. So that's why I put that not there. That just inverts this. When this is false, not false is true. This reads while true, n plus gets 1. Okay, now it does it again. Next one, not whatever this is, so let's say n is, say n is 9, right? So I check 10. Is 10 prime? 10 is prime is false. Not false is true. N plus gets 1, so n is now 10. N plus 1 is 11. That's a prime number, so that gives us true. Not true is false. That exits, and then since we checked if n plus 1 is prime, we have to return n plus 1, because that was the number that we checked. Okay, hopefully that's clear. I'm assuming that probably a number of you are still a bit confused with while loops. We'll get into them soon. I wanted to give you a little bit of a window. I kind of like to introduce a concept at a glance. That way, when we actually dive into it, you've seen it before, and it's not totally new. So don't worry if all that doesn't make sense. If you're like, I have some questions, or if you totally don't understand, like, not to worry. We will come back to it. You can set that aside. We'll do other things for now. Okay. We're not going to do the nth twin prime pair function because, I mean, you can try that. This is somewhere in learn. There's a twin prime function. There's also a next prime function in learn somewhere as well. So let's move on. Let's go into, there's one more thing. We talked about accumulators. Continue. So I talked about break. I want to talk about continue now. Continue is useful when you want to skip one iteration of a loop, right? So let's say, I just have a list, or Oh, we'll just do this in a range, actually. For I in range 10, if I do something like 100 over I, why don't I just print 100 over I? Anybody know what's going to happen before I run this? It's actually going to happen, well, I mean, a legitimate way to answer this is to type it in Replit and run it and see what happens. Yeah, it's going to give me an error. So what is that error? What error is it going to give me? Division by 0, yep. Because the first number in this range is a 0. Now, the obvious solution is to start the range at 1. But an alternative is to say if I equals 0, continue. So that's going to give me the error. If I do the continue, that's going to be okay. So what this continue does is it skips, it's like a break, but just for one iteration. So it skips to the next iteration. I always thought continue would have been better named skip. If it helps to just think, you know, if you're thinking, oh, I wish I could skip an iteration, just use continue. If it helps to think of continue as skip, then think of it that way. But if I were writing the language, I probably would have called it skip, or like skip iteration and go to the next iteration. No, I probably wouldn't have called it that, but skip is more of a, I think, of a descriptive term than continue. Continue is a little bit of a weird word, but that's what it means. It means just continue on, you know, don't execute any more code inside this loop, just continue on to the next loop. That's all it means. So, can be useful, now you know. All right. We got a breakout, we got 2 breakouts in there. I think we'll just save those for a future time. Let's get into some of these list methods. So let's change topics. Okay. I've alluded to and mentioned that lists, we've talked about appending, but lists have quite a number of things we can do with them. Lists are the only mutable type that we've talked about. So mutability just means that we can change the list on the level of the list. We can change the list itself. We can't change a string. We can get a different version of a string. If we concatenate 2 strings together, that doesn't change either of the strings, just like adding 2 numbers doesn't change either of the numbers being added, right? 3 plus 5 gives me, it evaluates to 8, but it doesn't change the 3 into an 8, and it doesn't change the 5 into an 8. It just says 3 plus 5 gives me 8. So the inputs stay the same, the output is something else. So that's a pattern of an immutable operation. Strings are similar, right? Hello plus world gives me hello world. It doesn't change the hello into hello world, and it doesn't change the world into hello world. It just gives me another string. I have 2 strings, one hello, and another string world, and it gives me a third string, which is hello world. So when I concatenate strings. So those are immutable behaviors. Lists have mutable operations. So if I have an empty list and I append a number, let's say 65, I append the number 65 into the list, I change the list. Immutable types don't have any of those kind of operations. Mutable types do. So we're going to talk about some mutable operations for lists, as well as some other immutable operations. One thing you can do if you're exploring a new, remember I talked about importing? If you want to know more about importing, I feel like I've already made it sound more complicated than it is. It's not a complicated thing. It's like I said, we have material on it in Learn. You'll encounter it if you go through the material. You can search for it if you want. If you're when you're trying to learn a new data type or a library that you've imported, you can use there's a couple helpful built-in functions. So there's dir, dir, and help. And I'll show you how to use these. I use dir to give me a general idea of what's available, and I use help to give me like specific information on something that piques my interest. And I'll show you how to do that. So with dir, we have to print dir, and usually actually what I'll do is I'll do this in a terminal, IPython 3. Just play around in the terminal, and if you're in Replit, you can click in the output section in the console part and do what I'm doing here. You don't have to type in IPython 3. It's just already a Python shell essentially. So excuse me. Let's just do dir, and then let's give it a list, and just any list. Literally any list, just an empty list is just fine. So this is going to give me a directory, dir is short for directory, of all the methods that are for lists. Now these are only methods and attributes. These are only the properties of the list class itself. If you look through here and you look through here, you'll see some things in here that aren't listed in the directory, right? Like max, min, any, all. You won't see len in here, right? So built-in functions unfortunately aren't going to be listed in here, but the methods for the type will be. You still have to just kind of know, learn the built-in functions as they come. So if you're wondering, well, why are some things functions and some things methods? Join the club. I'm wondering that too. So notice it's kind of funny. I always find this really funny. Dir returns, notice the square brackets and the quotes. It returns a list of strings where each string is the name of the internal methods of the class. It's a little bit odd, but it's fine, I guess. Okay, so what I should explain this part. So what I do is you can look through here. Anything that starts with underscores, the dunder methods or the magic methods, I'm not going to talk about these. You don't need to be concerned with these for now. These there's a whole other story with these. So I'm just going to look for any normal named method and copy those, and we can pop them in here. Cool, so these are all the list methods. You've got append, clear, copy, count, extend, index, insert, pop, and remove. And that's a good chunk of what we've got over here as well. So if you ever want to learn a new type and just find out what methods are available to it, dir is really good. If you see a method that's interesting, so let's say you look at insert and you're like, oh, I wonder what insert does. You can do help, and then you'll do list, the name of the type, or just the type literal. So you could do square brackets, dot, and then the method name that you're interested in. You don't want to invoke the method. You don't want to put the parentheses after it, because you're not trying to call it, you're just trying to specify which one you're interested in. So you need to leave those parentheses off, which is really weird, but that's how it is. Then you can run help, and it'll give you the help docs. For those of you who are curious, you've heard me talk about doc strings. This is the doc string for index. This is literally somewhere in Python, there's like a def index inside the list class where this exists, and this part is the doc string. So that's why doc strings are helpful, because if you use help, it'll find your doc string automatically. Okay, so it returns the first index value. Oop, I said index. I wanted insert. I think I said index all that time, and I wanted insert. Insert. Okay, so insert. Method of built-ins dot list. So it's a method of lists instance. Insert an object before an index. So notice index object, insert object before index. So it takes in an index and an object, and it puts the object at the index before the index that you specified. And we'll look at that and how to use it in a second here. Okay. So I'm actually just going to go through all of these like this. We know about append. Poplin, sort, reverse, sorted, reversed. Let's do these. We'll do these kind of together. Min, max, count, pop, len, sum. Len and sum go together. Feel like these should go with min and max. Any and all. Count, index. Is index not in there? Enumerate. Oh, it's interesting. Index is totally not even in there. Okay. Okay. I feel like maybe I want to do these first. So let's just cover some of the built-in functions first. Then we'll get into, actually let's get into these next, because I've already showed you append, and these are kind of all of a piece, and then these are mutable, immutable methods. Okay. So these are all built-in functions, and none of them cause a mutation in the list. So let's say list. Okay, so len, print len list. This is just going to tell me how many elements, the length, how many elements are in the list. Notice this is not the maximum index. This is the number of elements. So 0, 1, 2, 0, 1, 2, 3, 4. 4 is the maximum index. It's the highest index. And len says 5, right? So there are 5 elements. So that means my max index is len minus 1. Len, as you might recall, is often used with range. If you want to loop through a range, you want to create a range equal in length to a list, you can do range len list. You can pass the list to len and then pass that call to len. You can pass that to range. Cool. So sum works for print sum list. This will give us the sum of all the numbers in the list. It's 22. If I add something in here, that'll give us, change the number. If I try to do like a sum of a list of words, I'll get an error. So it says unsupported operand types for plus between int and stir. So it doesn't know how to add an int to a stir. I assume this is an accumulator pattern of some description under the hood, or it just has that error baked in some way. So yeah, so we can't do sum on any list. It has to be a list of numeric values that we could add together and get a sum of. So something to know. Max print max list. Oops. And let's do min. So max is going to give me 7, which is the largest number in the list. Min is going to give me 2, which is the smallest, right? You got to be a little careful with this bit, but if you do, oops, because this can be a little counterintuitive, interesting nonetheless. If we do, let's just do A, B, C, D, doesn't matter. So if I have a list of strings, and this doesn't have to be these don't just have to be single characters, but min and max will work with this. So what it's going to do is it's going to go by the Unicode, the ASCII value, ASCII/Unicode value for each letter, right? So those are essentially integers represented in binary that just correspond to character values in the ASCII and UTF-8 Unicode standards. So it's a little weird, but another way to think about it is like 7 comes out after 6 in this list, right? So 7 is the max because it's the number that comes the latest. It's the largest number. D comes after C in this list, so it's the largest. Similar logic, although it's weird when you apply it. It's not as intuitive when you apply it to characters. Banana. Cookie and dog. Dog. Oh, cat. Cat. Apple, banana, cat, and dog. So you can see it'll work with words as well. So it's a little weird. I always find it weird that it seems like there was like some effort gone through to like make min and max work with lists of strings. I don't know. They work with strings. Go figure. Cool. Any and all. These are another pair that go together. So any and all have to do with this idea of truthiness and falsiness. So if any of the values in a list are truthy, any will return true. If none are, then any will return false. If all of the values in a list are truthy, then all will return true. If only some or none are, then all will return false. So I think it's kind of safe to say that all is kind of like a like an and any is kind of like an or. If you want to think about it that way, if that doesn't make sense, don't worry about it. I don't know if I'm missing out on something. I don't think I ever use these. Perhaps I'm missing something obvious. There's like some place where it's just really great to use any and all. Perhaps I haven't done a kind of coding that where these are obviously useful. Or perhaps it's just the way that I code. I just solve the problems that these are well suited for solving in other ways, so I just don't end up using them. I'm not really sure why, but I'm not sure that I've ever used these beyond demonstrating them. But if you're curious, I'll be really brief with these because I'm not totally convinced if they're that they're that useful, because I don't really use them. So let's do all, and let's say 0, 5, and 7. That's going to be falsy because 0 is falsy. So if I change that to 1, that'll be true. False and true. Let's do something similar with any. So both of those are going to be true, and it's only going to be falsy when, or false when these are all falsy. And I went with integers for these, but I could do mixes of integers and floats and strings and other truthy falsy types. I could even do trues and falses, what have you. So if you're curious, that's any and all. Okay. So I want to show these together. Sort and sorted, reverse and reversed. So 2 of these are functions and 2 of these are methods. The methods are an in-place operation. What is meant by in place is essentially mutable. It's a synonym to a mutable operation. I think there are out of place operations that are considered mutable, like where something happens out of place, but you can, when you hear something is an in place operation, it necessarily means it is definitely a mutation to the object. So let's do this. Let's say print list. So that's going to give me my list. And then I hope that, gosh, I just realized, well, that's big enough. This is the size. I was like, oh, is this text too small? But I think this is the size I always have it at. Maybe I have it there, sorry. I hope that's legible size. Okay, cool. So if I sort this list, right now I'm just printing it, right? If I print list dot sort, this is a mutable operation. What do you expect it to return? I'll give you a second for this one. What do we expect this to do? So I've sorted it. We know sorting, well, I guess if you don't know, I'll explain what sorting is. Sorting is just it's gonna put all the numbers in order from smallest to largest. And there's several other options you can pass to any sorting algorithm that'll, or any of Python's built-in sorting algorithms that'll tell you maybe you want it largest to smallest, or maybe you want it this way or that way. There's several different kind of things you can sort against, but in a standard sort, it's smallest to largest. Should print 2, 3, 4, 6, 7. Okay, so the question on the table is, given that, if you understand what I just said about what a sorting algorithm does, which I'm assuming you know, if not, let me know and we can go over that. But so what is line 150 going to print to the console? And again, an acceptable way of answering this question is to super secretly, without ever letting me know, that you ran it in Replit. No, you should definitely run it in Replit. Go ahead and run it in Replit, or your local environment, or whatever environment you use. Returns a copy of the original list sorted from lowest value to greatest value. Arrange values in list, small to large. Yep. None. Interesting. Anyone else? Any other takers on this highly mysterious question that I'm asking? I'm seeing a lot of people not running the code. Go ahead and run this. Go ahead and run this in Replit. I don't know anything about programming that I haven't proved by like seeing it in a terminal, basically. There you go. Now y'all are running it. Right, so if I run this, none, right? So this, and I hope this doesn't come off as like a dirty trick or something where I'm like, ha, I got you, doesn't return anything, right? Like, I'm not trying to get a cheap laugh or something. I'm trying to, and I saw somebody just deleted their answer, like, don't worry, this is not about like having the correct intuition. It's about noticing whatever your intuition says, or running the code and looking at it and seeing what's going on, right? So it's, the reason I'm doing this and making you kind of think through this is using mutable operations can feel kind of counterintuitive. Somebody gave a very succinct answer. Returns a copy of the original list sorted from lowest value to greatest value. That is exactly what the sorted function does. The sorted function does exactly what you said there. So the sort method sorts it in place. It does not return the list. So you think, well, who cares? Why is it useful? Because it changed the list. This list is now sorted, right? So if I take the ID of this list and the ID of this list, I mean, they're the same list. They're the same list, and because they're the same list, they're going to have the same ID, but they're not going to have the same value, right? So same ID, different values. It's like if you took your car in to go get it painted, you mutated the paint color, right? It's you wouldn't say, oh, it's a completely different car with a different VIN number, like an ID. It's the same car, you just got it painted, right? So I just want to address this, and so that whenever you use something in a mutable type that you think might be a mutable operation, you can start keeping a mental model. You can start keeping track of what things cause mutations and what don't. So sorry if I don't mean to put anybody on the spot with that exercise or anything. I'm not trying to embarrass anybody or like get a cheap whatever laugh or at y'all's expense or anything. It's just, you want to start developing an intuition based on what you've used and how you've used it. So that description that somebody gave unsorted about returning a copy with the elements sorted, that tends to be more desirable behavior in most cases. That tends to be how you want things to work. The way I think about mutable operations is that they're useful like when you don't have another choice. If you can get away with copying something and getting a transform of it, it tends to just be easier to work that way. You're not altering data, so you kind of have a sense of where and how things are. Um, so yeah, so let's just look at this again. Let's print list, and then let's print sorted list, and then let's print list again. So the question is, now let's do this. I forgot to really ask the last time. I forgot to really ask to frame the question in terms of like, what's your intuition? That's really how I mean these to be. So what's your intuition tell you? I'm going to print list. I'm going to print the sorted list. Line 158, is it going to be sorted or not? Thumbs up or thumbs down about does your intuition tell you that line 158 will print a sorted list or an unsorted list? And to be clear, this is the line that I'm talking about, sorted or unsorted. Thumbs up if you think it's going to be sorted, thumbs down if you think it's not going to be sorted. Okay, cool. Let's run it. Let's check it out. So we've got our unsorted list, our sorted list, and then the list is back to being unsorted, right? So this is a great opportunity, right? Like because you have to be, it pays off to be totally clear on when and how things change, right? You don't have to have a perfect picture of this right now, but it's something that you will work towards to be able to keep track of what operations cause a mutation and what operations don't. For the operations that don't, we call those immutable operations. So sorted, the function, doesn't cause a mutation. It's immutable. It's an immutable operation or an out of place operation. It returns a copy, right? So now you can think about your program. If you want something to change, if you want to change it from an unsorted to a sorted form and change it, you can use the sort method. If you want to just get a sorted version of it without changing it, which in my opinion, in most cases, tends to be more desirable behavior, unless there's some performance reason why you don't want to do that. Like if you're dealing with something that is, has, that's just like massive, like millions or billions of data points in it, copying it arbitrarily might not be a good idea. It might become more interesting with those larger objects to do in-place operations and kind of make the most of limited space. But most of the time, I mean, you're working with lists like this, like when things are small or medium or even kind of large, you can get away with doing out-of-place operations like this. So that is my opinion, and I'll just frame it as such, but I'm sure others would disagree with me. There's sort of an old guard of old school computer science that is very focused around doing in-place operations and doing mutations as a very preferable way of doing things. So if you encounter other people who differ in opinion from that, be warned. They're not entirely wrong, and especially like if you learned programming or computer science in the 80s or even the 90s or even through the early 2000s, or even now if you learn in a conventional academic institution, those ideas are still pretty entrenched. But definitely in the 80s and 90s, like, RAM was a pretty hot commodity. It was a pretty limited resource, much more than it is today. You could just be doing a simple fun toy project and run out of RAM, whereas now, like, this kind of beginner coding, we've got RAM for days and days and days. We're never going to run out of RAM, just playing around and learning a language, so different set of priorities. We're going to get to reverse and reversed. We're going to have to get to that next time, but it's the same sort of pattern. Reverse is a method. It causes a change. It reverses the elements in the list. Reversed is a function. It doesn't quite behave exactly like sorted. It gives us a list reverse iterator object, which is its own thing, but it can be cast to a list. So essentially it does not cause a mutation and allows us to iterate through an object or a list in reversed. So again, the function, in my opinion, is preferable to the method. We talked about append before. I kind of feel like if you kind of have a sense of how to work with lists, you're probably feeling okay about append. I'll cover that again next time, and we'll get through the other operations next time as well. Cool. All right. We'll wrap up there. If people don't mind staying on just for 1 second, let me get the recording stopped.